Standing on the shoulders of giants. This is the story of PostNL, how we embraced serverless technology, what it has brought us, the challenges we faced, and how we overcame them. My name is Luc van Donkersgoed. I'm an AWS serverless hero and principal engineer at PostNL. And PostNL is the Dutch National Postal Service. We deliver an average of 1.2 million parcels per day. We have 34 sorting centers, and we employ over 35,000 people. So in other words, we have a very large logistics landscape, which is controlled by advanced logistic processes and algorithms. The application landscape powering these processes consists of over 70 applications, which are built by more than 30 in-house development teams. PostNL is also a very old company. We have been around under various names since 1799. So this year, we're celebrating 225 years of history. Now, of course, you don't get to the ripe age of 225 without adapting to constant change. Among many other changes, PostNL has adapted from horses to cars, from physical post offices to the internet, and from letters to parcels. In the past few decades, software has really become an inextricable part of PostNL's operations. But the way we approach software has significantly changed since 2012. Before 2012, we mostly used commercial off-the-shelf and vendor-built solutions, which were hosted in our own private data centers. In 2012, we decided that maintaining data centers should not have our focus, and we migrated everything to AWS, which made us one of the first European enterprises with a public cloud-only strategy. In 2018, we realized that to remain competitive in a fast-moving environment, we had to build our own logistics software. In other words, we had to become a software engineering company. We explored our options and we found that serverless and cloud-native solutions on AWS were the best fit for our business, and we shaped our engineering community and our engineering department to optimize the use of these platforms. So, why choose serverless as the foundation of our new engineering strategy? There are a few reasons. The first is elastic pricing, or pay-per-use. And this is very relevant in a business like PostNL, because in an average week, the load on one of our applications might look like this. So, as you can see, we hardly process any requests during the nights and on Sundays. But on Tuesdays, and especially around noon, we experience very high loads. This is both when all of our delivery drivers are out, and also when our customers are using our apps and websites. But because our entire landscape is serverless, we hardly generate any cost during these off-peak hours. And with patterns like these, this can lead to big cost reductions compared to always-on systems. The next reason to choose serverless is effortless scaling. Of course, scaling is an important property for weekly patterns like the one on this slide. But this pattern is not the only seasonality that we have at PostNL. Here we see another usage pattern, this one covering about 6 months. You can still see the weekly seasonality because every one of these bumps is a single week. But you can also see another pattern, which is an increasing load towards the end of the year. So, can you guess what causes this pattern? It's the holiday season, because in December and January, we process significantly more volume than in the rest of the year. And even in the weeks afterwards, we process significantly more return volume. But by embracing serverless, we don't even have to think about this increased skill because our applications automatically adjust to the load. Now, of course, our AWS bill will be a bit higher, but as we're processing more parcels as well, this cost is automatically covered by increased revenue. So we've covered elastic pricing and elastic scaling. And these are great attributes to have in a serverless application landscape. But to me, these aren't even the most important arguments to choose serverless. So let me ask you another question. Can you tell me what the two most expensive components in software engineering are? Now, this is a Zoom call, so I'll answer the question for you. The two most expensive components in software engineering are human labor and outages. So let's dive into these two topics. The most common cause of outages are infrastructure problems. So among other things, I'm talking about hard drives filling up, physical hardware failing, network congestion, and misconfigured network configurations. There are so many moving parts to infrastructure that implementing and maintaining them is an extremely valuable specialism. And as an enterprise, you must do it right, because outages are super expensive too. If our logistics network is down, for example, our sorting centers stop to work, our delivery drivers can't work, and maybe our customers will demand compensation. Now, this also means that if you make your application builders responsible for their core infrastructure, it will take them significant time and effort, which isn't spent on creating customer value. Now, alternatively, you could maintain distinct operation or platform teams, but these are very expensive as well. And generally, these teams are not a core capability for enterprises. Remember, we moved away from private data centers because we did not want to maintain those systems. So instead, PostNL chose to mandate the use of serverless. And this allows us to delegate the most difficult infrastructure problems to AWS. For example, we don't think about physical CPUs, their capabilities, their compatibility, their instruction sets. We just use Lambda, step functions, or Fargate, and AWS manages the physical capacity. Likewise, we are using a network to communicate between our applications and services. But we don't have to think about volumes or bandwidth or speed. AWS just automatically manages anything we can throw at it. And then there's high availability. And this is an extremely important, but also a very complex topic. It involves availability zones, failure detection, failover, immutable resources, and many more complex challenges. But with serverless, we just get all of this out of the box. We write an object to S3 or a message to SQS, and Amazon takes care of the rest. And another great benefit of using managed services is the security responsibility which is carried by Amazon. For example, when the Log4j vulnerability was found, Amazon patched their operating systems, their applications, their runtimes. They even patched Lambda to protect customer application code from abuse. And likewise, they patched their infrastructure when the Heartbleed vulnerability was found, and no customer action was needed. And I think this diagram is such a great way to tell that story. All the way on the left, we have on-premises. And as an enterprise, if you use this pattern, you're responsible for everything. physical infrastructure, data centers, access control, hardware, software, applications, containers, the entire thing. Well, all the way on the right, we have serverless. And now Amazon manages the physical infrastructure, the virtual machines, the operating systems. And if you use services like SQS or SNS or DynamoDB, Amazon even manages the application itself. So what are the results? After 5 years of using serverless, PostNL has significantly reduced the number of incidents and outages. We have also created dozens of teams, which together have released thousands and thousands of features over the years. We've also brought down overhead, both in a financial as well as in a productivity sense. And because we moved our development in-house, our teams are now much better aligned with organizational and strategic goals. So we embraced cloud native services and serverless, and we never looked back. It's all roses and unicorns in serverless land. Or is it? Of course not, because nothing good comes without a cost. So let's talk about trade-offs. As any software architect will tell you, everything is a trade-off. And embracing serverless is no different. So let's take a look at 4 common arguments which are commonly used against AWS serverless and cover their trade-offs in turn. First, serverless locks you in. And this might be the most common argument against serverless. And honestly, I'm not even going to argue. It's true. If you embrace serverless, leaving AWS is going to hurt. But what is the alternative? You can try to avoid AWS services as much as possible and invest like in other platforms like Kubernetes. But then you take on the responsibility of building and maintaining that platform yourself again. With serverless, you're locked in, but as a trade-off, you get to delegate platform maintenance entirely to AWS. The second argument is that serverless is expensive. People say running enterprise production workloads on serverless will break the bank. And in this case, I might agree on the cost per event or the cost per request or the cost per gigabyte stored compared to other systems. But again, this is a trade-off. Because for this price, you get all the benefits we discussed before: scalability, maintenance, security, and hundreds of new features every year. And this at no additional cost. And again, remember the price of outages. By using a stable and highly available platform like serverless, you're reducing the number of incidents. And if you include these variables into your total cost of ownership, you will find that the higher price per request might be well worth it. The third argument is that serverless is too complex. A simple application requires at least 4 services, and you need to know exactly how they work together, how they feel, how they scale, and what their limits are. But I would argue that this complexity is actually a good thing. Because in fact, an application on EC2, Kubernetes, or in your private data center likely has the same components. They simply might not be visible, or they might be embedded in the inner workings of your application, which means, again, that you're responsible for maintaining it. Serverless brings complexity to the surface, where it can be documented, debated, replaced, and analyzed, all while Amazon is responsible for its operations. And the final argument is that serverless is too opinionated. And again, I'm not even going to debate that serverless is opinionated, because it is, and very highly so. But most of the time, this is with good reason. The limits and restrictions imposed might protect an internal architecture, or they might force you to use the service the way it was intended. Or it might protect customer data in a multi-tenant system. The way we see it is that it's better to work within the limits of an opinionated system instead of against them. So let's explore the topic of opinionated services a little bit deeper. It is no secret that Amazon builds services for scale. For example, Amazon S3 processes 100 million requests per second. DynamoDB peaked at 126 million requests per second during Prime Day 2023. And Lambda processes more than 10 trillion invocations per month. So running infrastructure at those scales requires very strict architectural principles and operational excellence. So AWS has decades of experience designing, building, and maintaining the largest applications and services in the world. They have experienced firsthand what works and what hurts. And the services in the serverless ecosystem are the embodiment of that experience. So by using serverless services to their fullest extent, your application automatically achieves a base level of maturity, which typically takes years to build. But of course, embracing serverless does have an impact. For example, if we're using serverless to its fullest extent, we need to know its capabilities inside and out. If serverless is expensive, we need to know how to optimize for cost. And if serverless is complex, we need to train our engineers. And if serverless is opinionated, we need to know the rules of the game so that we can use them to our advantage. So what does this mean for a serverless engineer at PostNL? What skills do they need? What challenges do they face? Of course, they need to be very familiar with the serverless ecosystem. They need to know about the available services, their use cases, their limitations, their failure modes, and how multiple services like SQS, SNS, or EventBridge compare to each other. They also need to be able to design for scale. For example, they need to think about queues, buffers, throttling, and exponential backoffs. But at the same time, they also need to think about the operations of their workloads. Which metrics are important? What alarms should they configure? And how are they going to make their applications observable? And finally, they have to design with cost in mind. Of course, they could just throw every event into DynamoDB, but they have to wonder, is that really the best solution? Maybe SQS or Kinesis Firehose and S3 could be used to solve the problem more cost efficiently. So on the previous slide, we mentioned operations shortly, and this is really one of the challenges and tasks that our engineers have as well. They operate our own workloads, which means that they have on-call rotations and they respond to incidents. After all, even if the Lambda service itself might be very highly available and almost never goes down, your application might still encounter an unexpected input. Now, hopefully, this results in a controlled failure, such as a message placed on a dead letter queue. But it is then up to the engineers to find the root cause, to solve the root cause, and maybe redrive the message. And another common problem in serverless environments is hitting a service limit, such as the maximum number of concurrent Lambda invocations or the maximum number of API gateway requests per second. And when this happens, engineers need to work with AWS to resolve the limit as soon as possible. And then the next day, they need to look at their architecture and make sure they avoid hitting this limit in the future. And this solution, again, might involve some architecture like a buffer or queue, a throttling system, or exponential backoffs. So in summary, our engineers need the knowledge to know what tools and services are available to them. And they need the experience to make the right decisions. And this is not easy. It requires long-term investment in people and culture. So one of the ways we do that at PostNL is by investing heavily in formal education, such as classes and workshops. We also foster our engineering community by hosting knowledge shares and community-led tech improvement chapters. We have found that continual learning and sharing our experiences is essential to support a cutting-edge software engineering company. At the same time, we've also seen that a very effective way to promote good serverless engineering is by making the right thing easy. For example, we offer one-click solutions to deploy new AWS accounts, which are then automatically integrated in our network architecture, our version control, cost monitoring, and security tooling. But of course, we also need strict guardrails. For example, we put service control policies in place, which prohibit the creation of EC2 instances and IAM users. And this forces our developers to make the right decisions regarding cost, security, and operational overhead. So what have we learned? Embracing serverless in the enterprise is good for cost and reliability. But embracing serverless is not a flick of a switch. You need to invest in your processes, in your guardrails, and the AWS platform itself. You need to make the right thing easy and the wrong thing hard. And most of all, you need to invest in your people and hire the experts who can build your serverless future. And we have seen that the more we invest in serverless, the more we can delegate to AWS. They become responsible for almost the entire stack, including its high availability, scalability, reliability, and security. And because serverless services are built to perform well under the highest workloads imaginable, and they have decades of experience ingrained in their architectures, we have found that by using serverless, we truly can get to stand on the shoulders of giants. Thank you. That's it.
Wow, that was awesome. Very good.
Thank you.
I love
Wow,
that
I feel
story.
like I
That's nice. I like it.
want to relearn serverless all over again.
Yeah.
It's a lot of people. Welcome, everyone. I hope you enjoyed it.
So Luke, what do you find has been the hardest thing to teach people about serverless? Because obviously you said PostNL has like 35,000 employees. I know not all of them are engineers, but I'm sure you have a decent amount of turnover in the engineering department. What is the hardest thing to learn in your experience?
I guess it's actually not technology, it's the business. If you have such a large company, there's this giant process, how we get to features, how we get to value. And there are so many cycles and so many ways engineers can also add value to the company. But to actually understand how or what that value is in such a large company is quite difficult. So keeping in touch with the actual value streams and such is, I guess, the most challenging. From a technological perspective, I think there's we also have quite a lot of history. So we have old applications, but also people who have worked in PostNL for a very long time. and they've seen technologies come and go, and this story also helps to teach them about what the actual value is of serverless and why you should use it, because to them they might think, well, you have this DynamoDB table, and now I have to do all these things with partition keys and sort keys, but I've used MySQL for 20 years and it always just worked. So why do we actually need this? And then getting to that point, like, yeah, but a database is something you have to maintain, and it might not scale into the future. Having that conversation over and over again is really valuable, and maybe for at least a section of the organization, also one of the challenges we have.
I also noticed that you said that there was a mandate for serverless, and what does that mean? Because a lot of us here, like, I can look at all these faces on the screen, and I can tell everybody here does a serverless first approach, or at least most of us do. But we always put that caveat in there that it's not serverless only. So what does the mandate entail?
Okay, so I guess when you log into your AWS accounts, you generally have admin permissions, right? So if you go into EC2 and you say, I want an EC2 instance, and it's, I don't know, a G4 DM16X large, you just press the button and you have the thing, right? We get a very large red banner that says, IAM access denied when you do that. You just can't. No EC2 instance, like none. I couldn't start a T4 Nano. Well, I mentioned service control policies in my talk. That's how we do it. So we actually give everyone admin permissions, and then we apply service control policies, which limit some of those, including which regions they can use, and the fact that you can't use IAM, you can't create IAM users, and you can't create EC2 instances.
Do you
So that's
see
a
a
mandate.
future where that might become a flexibility thing, right? Depending on it. So interesting. You said I didn't want to say that I had admin privileges, right? But I do, and I'm not prevented from things like that. And again, yeah, SCPs really help. But how would you extend if there truly is a use case, or you don't see a future where you could find a need for that? That would be a nice future, though.
Yeah. So it's really well, I guess we have categories of applications which are organized in organizational units, and for anything that is a production workload, this is the rule. But for example, we also have machine learning teams which are not in the production flow, but do exploration and so on, and there the limitations are less restrictive. But another example, last year I had to build a feature that involved signed URLs. And we wanted to use signed URLs on S3. But if you create a signed URL on S3 using a Lambda function, the lifetime of the signed URL, whatever you set it to, if you set it to 1 day or 2 days or 7 days, whatever, it's actually limited to the life cycle of your assumed role of your Lambda function. So it's never more than an hour. That took a little while to find out. So now you know. Anyway, if you look at the documentation, it says you can do two things. You can create an IAM user, which has long-lived credentials, and use that to sign your URL. Or you can use CloudFront signed URLs instead of S3 signed URLs. But we already had the S3 solution. So I called up our CCOE, which manages all these permissions and so on. I said, I have this use case, and I could really use an IAM user for this because of this reason. And he said, no, you just have to rewrite it in CloudFront. Just not going to do it. And they were right to say so, actually, because now that I look at it, now we have CloudFront and it works perfectly. You have key pairs and it's all good. And it's a much better solution than the IAM user one, even though it took us another week to actually build this solution. So, yeah.
I have a question. You mentioned that you can't run the EC2, but you mentioned also in your presentation that you're using Fargate, right?
Yes.
So what if you will pick the biggest Fargate possible configuration? You can run it?
Yes, you can, and teams are responsible for cost. So we monitor cost, but we don't restrict anything there. If you need those Fargate containers, then you're free to do so. But then if your bill is significantly higher than the next comparable
Okay,
team, we
so
will have a
it's more
chat.
like technology option rather than cost, right? In that case.
Yes. So what this
Okay.
is all about is about operational overhead. So we want to restrict the options that might lead to a high operational overhead. And simply blocking all of EC2 is a very efficient way to do that.
Okay, good. With the regarding the example that you said with S3 and signing, if you will assume role and you will on this assume role use these credentials for generating this pre-signed, it can be also longer than 1 hour, right? But I'm not sure.
I think when you
how-
assume a role, the maximum lifetime is a day or something. I'd have to look up the docs, and we
or
wanted 7
days.
days.
I'm not sure, but or 7 days. Yeah, yeah.
Yeah, so yeah, it didn't work.
Okay.
I think there's also a limitation that you can't create a pre-signed URL maybe that outlives the duration of your role session too.
That's it. As soon as that one expires, then the signed URL just returns a 403.
When did this serverless mandate go into effect?
So sort of right from the start, when we started to do in-house engineering. So this is 2018, about 6 years ago. So I touched on this in the presentation, but before 2018, we didn't build software. So we had software, but we didn't build it. Partners did, or we used commercial off the shelf. So that's a really big change, a really big transition from going to delegating that work to external parties to doing it in-house. And well, we had the luck, I guess, of a very smart CIO. We said, well, if we're going to do this, we are going to do it right. So we actually took half a year. This before I joined, by the way. But we took half a year to investigate, like, what does that look like? But we already had this very strong partnership with AWS because we ran all those workloads in AWS. And well, if you have 35,000 people and a very large AWS bill, they're very happy to help you bring more workloads to AWS. So they also invested in us in helping us understand what that system might look like. So right from the start, right from when we did our first production workloads, the limitation was in place.
So that's, let me do the follow-on question to that. That's really early with, was there, I don't think you answered this just now, but like, that's a lot of trust that your CIO put into that commitment. What were the services that, do you know, like what the first production workload was that was moved over to it? Because there wasn't Event Bridge at that time. There wasn't any of these things that I know you guys were making full heavy use of.
No. So, you know, you have SQS, DynamoDB, Lambda, S3, SNS, all of that good stuff was there, right? And you can build pretty much API gateway. You can build pretty much anything on top of that. And EventBridge, you know, I love it, but it's just a nicer and easier way to do things that you could technically already do before. Same with step functions. It's really nice. But you could also solve that in another way, more complex way before that in a serverless way. I don't know what the first workloads were, but I do know they didn't start with the most critical systems first, of course. So it really went from the edges towards the core.
How long did it take to migrate everything over? Is everything migrated over?
No, it isn't. So
Okay.
everything is in AWS, but we still have older systems that were built or maintained by partners, which are still built and maintained by partners. So, and those might run on EC2, actually. So the rule, there's a slight nuance to it. If we build it and run it and maintain it, it has to be serverless. If the workload itself is not serverless, then we cannot run it or build it or maintain it, but our partners can. And they will do so in our AWS environment. So we own it, but we will not take the operational responsibility. Our partners will. We pay them handsomely for it as well. So actually, there is this long-term move to move as many of these partner workloads in-house because it's actually cheaper for us. Because these partners, well, they are expensive. You know what consulting fees are. And well, you can just hire expert engineers, multiple expert engineers for the same cost if you run it internally, but then we have to rebuild the application in a serverless way. But it happens all the time. Yeah.
So I guess Alan is finished. I have one thing, like it's super nice to see another company from Europe in this cycle this month. I have a question because I read your post about OpenTelemetry that you are using at PostNL, and you mentioned there that you were using, I guess, Exporter there using Kinesis. Can you say a few words about it? How it works for you in general in serverless?
It works really well. So as a bit of context for the people that haven't read that, I mentioned operating our workloads and having the visibility and observability on our platforms to actually, well, understand what's going on. The way I see it, you have monitoring and you have observability. And there's a slight overlap, but the way I see it, they're different. Some people call it observability 1 and 2 or 1.0, 2.0, whatever. There's a bit of a naming war going on there. But we found that with the services that AWS offers, we couldn't get the visibility that we actually wanted in our environments. So we investigated that and we came to the conclusion that OpenTelemetry is the future of observability. So we wanted that, but that is also not natively supported, not really natively supported by AWS. They have something that's called the ADOT, the Amazon Distribution for OpenTelemetry. I hate it. I really would advise anyone not to use it. Two big reasons. It's a very big Lambda layer. It's a very complex application that runs in your Lambda function. So if you have a Lambda function that has 128 megabytes and 2 milliseconds of execution, you add ADOT, and now it has 5 seconds of execution, and you need 2 gigabytes to run it. Very big, important reason. Also, if you run 1 million invocations, that becomes really expensive. The second one is ADOT has to export its telemetry to an outside location. And the only way it can do that is at the end of your Lambda invocation, as part of the extension it runs on, over a public network. So we use Honeycomb as our observability platform. We sit in Ireland, they sit in the US. So that adds 200 milliseconds round trip to every Lambda invocation just to get that telemetry off. So really bad design.
Like a couple of things here. Like first, regarding the ADOT, I'm not sure who implemented it, but I guess there is like not proper engineering on that layer. We had the issue back in the days, really in early days of this layer, that someone was logging stuff all the time. So it was pulling all the messages to the system out, and we were paying for that messages on the CloudWatch, of course. And we couldn't block it. And we went into the code of that layer, and it was print line. It was print line in Go. Like it was like everyone knows that it's bad practice, right? But they have fixed it. So it depends when you are looking at this layer, but it's constantly improved. And regarding this traffic to public network, it's not always the truth, because if you will use this gateway pattern for collecting telemetry, then it can sit in some component you have inside of your network. So you don't have to wait
Yes, but
too long for
we
the round
have an
trips.
entirely serverless landscape, so we don't use our own network. So now, yes, you could,
Okay.
but now I have to start a VPC, build an entire VPC environment,
Yeah.
put all my Lambda
Yeah.
functions in a VPC just to get the telemetry off.
Yeah.
So
Yeah.
doesn't work for us in any case. So what we did instead is build our own exporter, which is actually pretty easy to do because OpenTelemetry simply has an interface for exporting. You have to have, I don't know, a flush and a shutdown function, something. And in that function, we just write the telemetry in binary form to Kinesis. And just using the Kinesis Boto3 SDK. And that is like a 4, 5, or 6 millisecond operation. So that is actually, well, affordable in our at our scale if you run 1 billion Lambda invocations. So your question was, does that work well for us? So on one hand, yes, because this is really scalable. One problem we've run into is that Kinesis is like the only not dynamically scaling component in our landscape. So if we have a very large surge of invocations, which we sometimes do, then actually Kinesis can't scale in time or doesn't scale at all. So either it's very over provisioned and then a little bit expensive, or just throttles and then you get this backlog and it becomes a bit difficult. So what I haven't done this in PostNL, but what I've done for my own solution is exactly the same architecture, but using SNS instead of Kinesis. So now I'm writing my binary data to SNS, and then from SNS to 2 SQS queues, because I still want fan out. And then I read from SQS with a Lambda function and send that to Honeycomb. So I have the best of all worlds because I have infinite scale, and still it's entirely serverless, and I don't need ADOT and everything else.
Yeah, the only thing that can happen here that you can pay a lot for this SQS, right? In case of really high throughput, I guess. But I understand. The only thing that I would say regarding this OpenTelemetry and collecting that in the gateway, that the benefit of it is that you can do much better things in observability, like tail sampling, batching, these kind of things. We have our observability provider, for example, advised us to batch lots of messages when we are sending that to them. So you have some Lambda that is collecting that from the Kinesis, right, and putting them in the batches, right? In the
Exactly that, yes.
okay.
So I actually have a blog post that I still need to write, but just can't find the time that explains that. But we read from Kinesis like 10,000 lines, then we sample them, we do batching, we gzip that, and that's what we send to Honeycomb. So it's a Lambda function. It's a couple of hundred of lines of code because there's some complexity in there, and that is, I guess, the downside. But well, we wrote the Lambda function once, and it just runs forever, and we don't have to maintain a collector running somewhere in a container. So it's the same serverless mindset. You build it once and you have no operational overhead.
Have you seen a lot of, because I see a lot of friction internally around the developer experience of building serverless workflows? Is that something you recognize? This is particularly from people that come from container worlds. They're used to running their stuff locally, seeing logs immediately. They don't want to go into CloudWatch to see Lambda execution logs, sort of slow turnover on development cycles. Is this something you've sort of, or how do you deal with this? I guess it's.
Yeah. So yeah, a few things. Yes, this is true. It takes some getting used to. But if you say, well, we're used to containers, sure, but not everything is in that container. IAM is not in that container. SQS is not in that container. API Gateway, DynamoDB is all not in that container. If you want to use AWS in general, you're better off running or testing your systems in the cloud than locally. I think running your container locally is sort of a fake kind of
I think I agree, but it's for the developer cycle time when you do it in the cloud.
I was getting to that. So next thing. What we do have is sandbox accounts for every engineer, AWS accounts with well, let's say no limit, technically no limit on how much you can spend there. Of course, if it's too much, you will get a phone call. But we really promote deploying to your own sandbox as part of your development cycle. And we also standardized around CDK. So you can do the CDK hot swap if you're really developing just Lambda code. And otherwise, well, yes, it might take a little bit longer. So that's the last point I want to make. It's not perfect. It really isn't. But again, it's a matter of trade-offs. So, okay, it's not the same development environment as when you're running a monolith on EC2, but then again, you're also not running a monolith on EC2. So that's the trade-off.
Yeah, I was going to ask, Luke, I would add just like there's lots of ways to mock local events that you can use with SAM or with other ways to simulate the same stuff, which is none of it's perfect, but neither is running 5 containers locally to try to connect a bunch of services together that I've got to debug with 5 copies of Postgres all running at the same time too. So I was going to ask, so I love the mandate. I feel like Alan is going to take the mandate places. I don't know. You were really interested. I like it. No. So with the mandate, so how does that open up? I'm imagining that there's some autonomy in language choice, framework choice. Is this Dynamo? Is this something else? Like how do those decisions get made, and how much flexibility does the team have once they've leaned into the mandate? Which, by the way, I like, because you kind of are limiting people out in your hiring process, right? Like, this is the way we think. We have been successful. We would love to work with you, but this is the way we're going to operate. And I think being very clear up front is a really refreshing approach to talent enablement.
Yeah, actually, it works the other way around. So I go out and tell this story everywhere, and then people say, "Hey, I heard you on this podcast, and now I want to work at PostNL." So yeah, that works really well. Your question was like how does that work out in the teams? We give a lot of freedom and also responsibility, autonomy, you could say, to the teams, like how they build their solution architectures. So I was talking about databases earlier. We actually don't block RDS. If a team says we really need RDS or it's the best solution for us and our team, they can use RDS. If they want to run their Lambda functions in a VPC, they can. If they want to choose Fargate, they're allowed to as well. So there's a lot of liberty there. We have also a lot of liberty in the area of languages. So there's like 5 or 6 mandated languages. So it's Python, TypeScript, Rust, .NET, and Java, I think. So the teams actually get a lot of freedom, maybe a little bit too much, because there's a lot of diversity in the landscape, which does not help if you want to, well, switch teams or share technology or whatever. And then so we're probably actually going to limit that a little bit more in the future. But then there's other things that are non-negotiable, like you have to use the CDK, you have to put your code in GitHub, and you have to use GitHub Actions to deploy to production, so that we know that everything is in source code and versions.
No,
So
I
it's a
think-
bit of both.
No, that's super smart. I love the ability to have teams have autonomy. It enables that agility, right? And but at the same time, most of us without guardrails would hurt ourselves. So I think it's important to set those boundaries. That sounds fantastic. I think I want to come work for the parcel service now. I'm gonna throw up the website. I'm gonna apply.
Sounds good. Happy to have you. All right. Any other questions?
Have one if no one
Okay.
asks. So I believe that majority of your architecture is like event driven, right? Because
Yes.
you're okay. And how are you approaching the multi-region approach in that case?
Okay,
Do you have some
so
kind of sharding per region or?
I'm gonna have to go. I'm not at liberty to say. I'm sorry. Yeah, that's no, it's a bit of too much internal information.
Okay, understand. Thanks.
I have a question regarding the deployment pipelines. So you are mandating teams to use GitHub Actions, which is perfectly fine by me. But have you tried to experiment with the code pipeline and how that went, if you tried?
Yeah. So the way we standardize technology is actually pretty interesting, and I think a very good system. We have an engineering community, which is technically every engineer in the company. And we organize, let's say, quarterly charters. And charters are where a number of engineers who are strongly opinionated about a topic come together to find the best solution for PostNL. So, and very early days, one of those charters was, what are we going to use for infrastructure as code? And another charter was, what are we going to use for CI/CD and version control? And then those engineers come together and they compare all the products in the market and look at maturity, look at requirements, look at the fit for PostNL. And then they come up with a conclusion. This is the best tool that we should have. They present it to the CTO. And if they agree, then it becomes a mandate. So that way, CDK was chosen as the standard platform. And that way also GitHub Actions was chosen. And in that comparison, they looked at GitLab, at the code suite at Amazon, at Jenkins, at all the good and the bad stuff, and came to the conclusion GitHub Actions was the best solution. And from that moment on, it became mandatory. But this is a few years ago, and a few years ago, it was definitely the best choice to choose GitHub Actions over the code suite. Today, it probably still is. So even if they run the charter now, I think they will come to the same conclusions. Although we can now run branches in code pipelines since, like, I don't know, 2 weeks.
I've lived all in on Code Suite for several years. It's the right choice. GitHub Actions are great.
Yeah. Yeah, so I think that way to get to standardized solutions from the engineering community is really powerful, because you really get buy-in from the engineers, every engineer can join a charter. If you choose not to join a charter and they come up with a conclusion you don't like, then you should have been in the charter, right? It's a much better approach than top down. Some CTO saying, "Hey, everybody should use Jenkins because that's what I used 20 years ago," and that has no buy-in from the engineering community. So yeah.
All right. Any last questions for Luc? I see Marcin coming off off camera.
No, I just wanted to say congrats. Like really nice talk.
Thank you.
And
Appreciate it.
sorry for hard Q&A, but I'm really curious because we have
Oh,
some
well, no.
similar issues that I'm asking about.
I prefer the difficult questions. They're more fun. So if you want to hear more, I guess tomorrow, Alan, there's a podcast coming out.
Yes. Thank you for plugging my podcast on here. But yes, Luc and I have an episode not talking about PostNL really at all, coming out tomorrow at 7 a.m. Central Time, which I believe is 1 p.m. UTC. But where we talk about learning by fire, learning in production, which is a fun thing that Luc just got to experience with his AWS News site. So we talk about that quite a bit. And let's see. So this talk wraps up the real world serverless theme for February. So thank you. I think most of our speakers that spoke this month are here actually today. So thank you all that spoke this month. Starting in March, we're going to be doing EDA Madness. So everything is going to be event-driven architecture themed. So next Thursday, we have James Eastham from AWS coming in to talk about, I'm pretty sure he's just giving us an event-driven architecture primer, which I'm really excited to see. So everything, the next 4 weeks, we're going to be going all in on event-driven architectures with serverless. So excited. And Luc, thank you again. Really appreciate it. This was a fantastic talk. Great insights. Honestly, I wish you had come up with this talk like 5 years ago when when I had started. But thank you.
Welcome. Thanks for having me.